Today you're going to be learning about parametric equations. We're going to spend a couple of days talking about these. And today you will cover writing a parametric equation as a rectangular equation. You're going to write a rectangular equation of a parametric equation given the parameter. And lastly, you'll graph some parametric equations. Something I want to address before you move forward is that a rectangular equation is something you've known all your life. This is something that's expressed, so we usually have one equation that's expressed in terms of x and y. Now this could be something like y equals 3x squared plus 7. This could also be something like x plus 3 squared minus y plus 4 squared equals 1. So it could be just our regular coordinates, or it could be a conic section. A parametric equation we're going to look into, that is what's new to us today. Before you continue on with this video today, I actually want you to do the worksheet first. This was designed for you to discover all the material that you need from those three objectives, and it gives you a lot of support and understanding as to why we do the things that we do with parametrics. So go ahead, pause this video, complete the worksheet, and then come back and watch this video for some additional support. So the definition of a parametric equation is where we have essentially three variables, and one of them we call a parameter. So based on this kind of image of a dolphin that is coming out of the water, we can measure this x horizontal distance. We can also measure the y, which would be the vertical distance, which we would probably call height. And then lastly, we can also capture, okay, where is the dolphin after 3 seconds? Where is the dolphin after 5 seconds? So that parameter t is what's new to us for parametric equations. When we're graphing a parametric equation, it's very, very direct. All you do is you take the parameter that's being given, t in this case, maybe time, and we substitute in these values in our table into the x equals equation. So I'm going to substitute 0 in first and continue to do that down this column. I'll do the same thing for y as well, plugging 0 into the y equals equation and filling that in all the way down the column, t squared plus 1. The last column asks us just to express it as a coordinate point, which would be kind of like rectangular form, what we're used to seeing and how we graph items on the coordinate plane. So then what I would do is I would just take these coordinate points, 1, 1, 2, 2, 3, 5, and 4, 10, and then I can't even graph the next couple, they're off the graph. But that's okay. This would be what the graph of this parametric equation looks like. Our second example asks us to eliminate the parameter, so we're converting to a rectangular equation. The first thing that we want to do is take this x equals equation and solve for t. We want to solve for the parameter in this case. Okay, so when I do that, I get x minus 1 is equal to t. Our parameter, time, t, is what we're trying to eliminate. So then I come over to the second equation, which is y equals t squared plus 1, and I'm going to substitute in that parameter value I just solved for. So y equals x minus 1 squared plus 1. Then I'm going to multiply this out. This is really like two repeated binomials with an extra 1 at the end. And when I FOIL that together, I get x squared minus 2x plus 1 plus an additional 1. So we get x squared minus 2x plus 2. That's what y equals. Go ahead and put a box around that equation. I know that I'm done because this is a rectangular equation. It's in terms of x and y, and we only have one equation. Our third example today, we're kind of going in reverse of what we just did. We're going to write a parametric equation given a parameter. So we're going to take that parameter and we are going to solve for x. So t minus 3 is what x is equivalent to. Next, what we're going to do is take that y equals equation, that's our rectangular equation, and I'm going to substitute in place of x, this new t minus 3 value, because that's what we just said that x is equivalent to. Just like we did before, we're going to put this in standard form, so we're going to FOIL it, expand it fully, and I end up with t squared minus 6t plus 9. Distribute the negative 3 through, you get minus 3t plus 9. So we get y equals t squared minus 9t plus 18. The important thing to know is since we're writing a set of parametric equations, this means we need two answers. So we need both the x equals equation and the y equals equation in our final answer. So when you're asked to box these in, you'll want to place both of them in. A parametric equation has two equations. An x and a y equals.